Monofilament fishing line is fishing line made from a single fiber of plastic. Most fishing lines are now monofilament because monofilament fibers are cheap to produce and are produced in a range of diameters which have different tensile strengths. Monofilament line is also manufactured in different colors, such as clear, white, green, blue, red, and fluorescent. Monofilament is made by melting and mixing polymers and then extruding the mixture through tiny holes, forming strands of line, which is then spun into spools of various thicknesses. The extrusion process controls not only the thickness of the line but its test as well. History. DuPont made public in 1938 that the company had invented nylon. This new invention was the first synthetic fiber fabric that is commonly used in textiles today. In 1939, DuPont began marketing nylon monofilament fishing lines. However, braided Dacron lines remained the most used and popular fishing line for the next 2 decades, as early monofilament line was very stiff or wiry, and difficult to handle and cast. Early monofilament did, however, have good knot strength and very low visibility to the fish, creating a small loyal following among fishermen. In 1959, DuPont introduced Strands, a thinner and much softer monofilament line that could be used in a large range of reels, including newly introduced spinning and spin casting tackle. Strands monofilament lines soon became a favorite with many fishermen because of its overall ease of use, and it spawned a whole host of imitators. New materials, e.g., spectra are finding growing usage as fishing lines. Polyvinylidene fluoride sold as fluorocarbon is very much like nylon monofilament, but has several advantages. Optical density is lower, which makes the line less easily discernible. The surface is harder, so it is more resistant to sharp fish teeth and wear. Furthermore, PVDF does not take up water and it is resistant to UV light. It is denser than nylon too, which makes it sink faster and it will not float on the water surface. Dyneema is also becoming very popular and it is much stronger, but it is used mostly as a braided fishing line, because the elastic stretching is only a fraction of that of nylon monofilament. The contact with fisher bait is more direct. It is often used for deep water fishing from boats because lower diameters are used, which give less resistance to currents, and the low stretch makes bites easily detectable. Used monofilament fishing line is used in a huge variety of fishing applications. Monofilament is not advisable for deep water fishing, since it can absorb water, resulting in loose knots, and its sensitivity can decrease when it is wet. Monofilament degrades with time and can weaken when exposed to heat and sunlight. When stored on a spool for a long time, it may come off the fishing reel in coils or loops. It is advisable to change monofilament line at regular intervals to prevent degradation. Non-fishing uses. Monofilament fishing line is also used sometimes in medicine to test a sense of touch. The transparency of monofilament fishing line makes it desirable for special effects where objects need to look like they are floating in thin air. It has also been used for streamers, musical instrument strings, sewing thread, and bent in the shape of a staple for use as a septum-piercing retainer. Environmental impact. Discarded monofilament lines can present serious environmental problems. These lines are extremely difficult to spot when submerged in water, and fish, birds, and other marine life can easily become entangled, causing starvation, amputation, and death. Ingestion is also a serious threat to wildlife. Monofilament lines also present a risk to swimmers and scuba divers. The breakdown of lines, especially in streamers, leads to microplastics which may cause starvation or poisoning of organisms in soil or water. For these reasons, programs have been started to recycle fishing line to keep it out of the environment. Specialized containers have been designed to collect fishing line for recycling.